Let us read the question. Part A gives a diagram, a relation between two sets, and asks for its range. Part B gives a function written as ordered pairs and asks for the value of p. Here is what we are given. In Part A, the two sets and how they are connected, and in Part B, the function g of x equals 3 minus x, written as three ordered pairs. And here is what we must find: the range of that relation and the value of p. So here is what we are working with: a relation from set A to set B and a function given as ordered pairs. We want the range and the value of p. Before the algebra, let us picture Part A. An arrow diagram has two ovals. The left oval, set A, holds the objects, the inputs. The right oval, set B, holds their images. Set A has 4 elements, and set B has 5. Each arrow shows which element of B an object in a maps to. Let us keep the diagram beside us and read the range straight off it. Step 1. The range is the set of all images. So follow every arrow to its tip and collect those elements of set B. -1 maps to -5, 2 maps to 10, 3 maps to 15, and 5 maps to 25. 20 sits in set B, but nothing points to it, so 20 is not an image. So the range is the set of -5, 10, 15, and 25. Always write a range with curly braces, the set notation. Quick note: a relation is one of 4 types: one-to-one, one-to-many, many-to-one, or many-to-many. In our question, every object had its own separate image, so it is a one-to-one relation. Step 2, Part B. In every ordered pair, the first number is the object, and the second is its image. So the second number must equal g of the first. Let us write that relationship down before substituting. Take the pair with 4 as the object. Putting x equals 4 into g gives 3 minus 4. 3 minus 4 is -1. The image from this pair is p minus 10, and that must equal -1. Add 10 to both sides, and p equals 9. We can check with the other pair. G of 9 is 3 minus 9, which is -6. It matches, so p equals 9 is confirmed. Final answers. Part A, the range is the set of -5, 10, 15, and 25. Part B, p equals 9.